On today's episode, we're going to talk about wiring diagrams. This is kind of one of those tools in a technician's toolbox that really can be confusing because there's a lot of symbolisms or symbols and abbreviations and whatnot, so it can be really confusing. However, if you can really establish an understanding of a wiring diagram, it is hugely useful when trying to diagnose electrical problems in vehicles. So we're going to start simple and we're going to get complicated. We're going to go from known to unknown, and then we're going to establish kind of hopefully some new learning for you to be able to take with you to be able to color in some of the wiring diagrams that we gave you for some homework during this time. Okay, so let's establish kind of our circuitry. Okay, here we have a self-drawn wiring diagram that I put together. Very simple and basic. Okay, so let's kind of go over some of the symbols that we have here. Okay, so in this case we have a battery. Alright, which is going to be ending up right here. And then we have a load. Alright, in our case, this load is going to end up being a light. Okay, that's right there. These symbols, as if you've been following some of these episodes, is our ground. So anytime you see this, that is ground. So I'll go ahead and draw that in as well. Okay. Now all grounds are connected to one another through the chassis. Okay, so this ground here is in theory connected to this ground, which is then connected to our negative side of the battery. Okay, so that's negative, this is positive. So flow is going to be presumed to be going in this direction. Okay, and then obviously we have our wires right here. And these wires are going to connect our battery to our load, any other components in our wiring diagram. All right, so that's kind of how we establish our symbols to be able to decode kind of that whole entire process. Okay, so as we're going in here and figuring out our wiring diagram, every component or every circuit is going to have a power side and it's going to have a ground side. And our little legend that we have over here is going to kind of help dictate us to break down how we can tell which side's power side and which side's ground side. So let's start with what we do know. We know that this symbol is a ground. So I'm going to select green, and what I'm going to end up doing is starting at ground, I'm going to go ahead and follow this wire up until it stops. Okay, and I'll know it stops because it'll encounter a switch or a load or some sort where that'll be obviously no longer be able to travel. Okay, we have a ground over here as well, so I'm going to go ahead and color this in as green as well. And again, I'm going to stop once I get to my load here. Okay, another way that we could kind of qualify a ground is where we get to say ground equals 0 volts. Okay, so if you were to take a multimeter right now and you were to test out how many volts this wire has, it's going to be 0. Hence why we are coloring it green. Okay, and that'll obviously come into play later on when we are establishing more sophisticated circuits. Okay, so that's our ground. Now we have our power. Power always starts here in the battery, and that's going to end up being colored out here. Electrons are flowing through here into our load. Okay, and that's providing power to our light bulb. Alright, so as you can see here, we've colored our ground in green and our power in red. Okay, so this is very elementary, just to kind of get you an idea of how we're coloring in our circuitry. Okay, so I'm just going to delete this real quick, and the main reason why I'm deleting that red is due to the fact that we are missing some components in our circuit here. Okay, so every circuit is going to have a voltage source. Let me put that down here. Voltage source, which in this case is going to equal our battery. Okay, we're going to have a load of some sort, a means to do work. And in this case, it's going to be our light. It's going to have a ground, and it's going to have some wires. However, in our example here, you saw that when I have a connected completed circuit, the electrons are going to freely flow, and this light is going to turn on. And it's always going to turn on until either my voltage source becomes so low that it's not able to push the electrons or create the current flow. Then it'll slowly dim out, and eventually it'll just turn off. Okay, or the light bulb breaks, right? And then all of a sudden the electrons can't flow because there's too high of a resistance. All right, now that's not ideal in our circuit, because we want to be able to control when to turn that light on and off. So we need some sort of device that is going to allow us to do that. Okay, and in this case we want a switch. Okay, so here is our symbol. This is a very basic switch in our electrical circuit. So we need a control device in our circuit, and that's going to equal a switch. All right, now if I were to come in here, and I'm going to just quickly erase this, continue to draw in my wiring diagram, I am now going to have my power coming out of my battery. It's going to travel along this wire, and this switch, or I should say this, the wiring diagrams always indicate your circuit at rest. So in this case, the switch is open, meaning that the electrons cannot flow in the circuit, thus the light's going to be off, okay, in an open scenario. Okay, so this entire red part is our power. So if you were to cut this wire essentially right here, right, you could in theory electrocute yourself or get a shock. Okay, so let me back up out of there. Now, as you can see also on our circuit, we have an area that is not colored in. So that's going to dictate to us one of two other colors. It's yellow, meaning that's ground when the circuit is complete, or it's orange, which means that the power when the circuit is complete. So we notice that if the switch closes and the circuit is complete, the power is going to continue to flow out of this switch and into this load, like so. So we're going to end up coloring this orange because there's still going to end up being power flowing through. There's still voltage there. Okay, so that is our circuit as of right there. Okay, however, we're still missing one component in our diagram here, our very simple diagram. So let's go ahead and erase this, and let's add on to our circuit here. Okay, so we are missing a circuit protection. So we want to come down here and write circuit protection. And our circuit protection in this case is going to be a fuse. And it could be a circuit breaker as well, but the fuse is essentially going to allow us to regulate or turn off the circuit automatically if we increase our amperage too high. So a lot of automotive vehicles are going to have 10, 15, 20 amp fuses, pretty common. And since we've been covering Ohm's law, we know that if you know, our resistance goes down, our current goes up, which then that means our current goes up. It's going to go over that 20 amps, let's say it's a 20 amp fuse, and then this is going to end up being burned out, and that severs it, which stops the flow, and it protects the circuit from being damaged, because it would be a big pain to replace all the wires and it could cause a fire. A lot of safety hazards there. So let's go ahead and get out our highlighter here again, and again we're in our battery and we're coming through here, and the one thing we have to ask ourselves is, as the voltage or as the current is flowing through this fuse, is it going to change? Does it get stopped like our switch, or is it able to freely flow through here? Obviously it's able to freely flow, so it doesn't change our situation in our circuit, so that's why we color through it as we do there. Okay, so that is essentially a breakdown of a very basic circuit wiring diagram. Okay, we have to have these pieces right here in every single circuit. Okay, that is without exception. Okay, now it might not always be present in a wiring diagram, but it is there. Okay, so let me go ahead and erase this real quick, and let's get another example here to kind of be able to highlight and show you kind of what's going on. Okay, so let's go ahead and go into a basic series circuit. Again, let's start out with what we know. We know ground, so we start our ground here, and we're going to end up coming up here and drawing here into our battery, like so. Okay, and then obviously we have our ground here as well. We'll come up there and go into this side of the load. Okay, so we've established our ground. Now the next thing that we should be able to establish pretty easily is our power. Again, we go into our battery here, and as I'm coming through here, just like we did to the top, our first example, we come into a fuse. We can travel through that fuse, no problem, and then we go into our switch, just like we did before. Okay, so we colored that in. That is our power side of our circuit. And just like before, once this circuit is, or the switch turns on and the circuit is closed, power is then going to flow freely from this wire into our first light. Okay, and then obviously we're going to be able to, this load is going to be able to perform action there, or work. Now the question that we have to ask ourselves is, what is coming out of this circuit and into our second load or our second light bulb? Is it ground? Is it a part of the ground side circuit, or is it part of the power side of the circuit? Well, if we think about this real quick, if we do a voltage drop test on this, are we going to have voltage exiting out this light? The answer to that is yes. Okay, Kirchhoff's law dictates that we don't use up all the voltage until all of the loads have been used. So in this case, we're going to highlight this part orange because that is still part of our power side of our circuit. Okay, like so. So there you have a breakdown of our series circuit, and you can see how this might be able to help us when we go to diagnose something, especially if we're trying to look for a short to ground or an open, so on and so forth. So let's go ahead and get us another example here. This time we're using a parallel circuit. So again, I'm going to come in here and establish what I already do know. Okay, and that's going to be ground. Start with that. So we come in here with ground, highlight that into the battery. In this case, I'm going to come up here from the ground of the backside, and now I'm going to hit a branch. Okay, and because I'm still on ground here, I want to follow this branch down until I get to my first load, but then I can also follow that up into this load as well. Okay, so this entire piece here is part of our ground side of our switch. And again, now we can go in, grab our red, and now we're going to highlight our power side of our switch. So we go through the fuse, and again, just like before, we go into our switch. Okay, so that's our power side. And again, we can establish our orange because once the switch is closed and the electrons flow freely, we come in here and we establish our power once it is connected, power side. Okay, like so. And that's how you would end up being able to label or color in a parallel circuit. Okay, so we have some good examples here. Again, just to kind of get us in the idea, right? Very basic switch there. Then we have our series, and then we have our parallel. Okay, now let's go ahead and move over into an example of showing yellow or ground when the circuit is complete. Okay, and this is going to be established through essentially where the switch is located. So again, with our circuit here, we're going to start with what we know. So we go ground. So we go green up to here. Okay, and we have ground up the top as well. And this is very common what you would find in a wiring diagram, right? Usually we're going to start at power at the top and we're going to go down to ground. Okay, and that goes into our battery like so. Again, I'll come in here and grab red to start with power. We go through the fuse, come here into our switch. Okay, that should be very familiar with what we just kind of got done highlighting. Okay, and then because we're looking at power when the circuit is complete, that starts here at our switch, because when that switch touches the power, it is then being controlled and allows us to go into the light bulb to do work. Okay, again, that should be familiar with what we were talking about on the last page. Now let's go over here to this example. Again, we start with ground. We come in here like so. We're coloring in our ground. This time we go into the switch with our ground. Okay, all the way until it stops, because at rest the switch is open. Same thing here with our ground up at the top. We come in and we color that like so. Alright, now let's go ahead and get our power here coming out of the battery, flowing into our fuse, and flowing out of our fuse, and going into our light or our load. So this time we're bypassing the circuit from our power side and going right into our load. Does that mean that our light bulb turns on? The answer to that is no, it doesn't. Simply because, remember, this switch is open, so there's no flowing current. We have to close that switch in order to do that. Now in this case, because we went into our load with the power, what's coming out of our load is not power. Okay, this is part of our ground side of our switch because we're establishing where our load is. Okay, in this case I'm going to use yellow because yellow is going to dictate to me when the circuit is complete. That's going to turn green, if you will. Okay, and that's kind of where we go. So essentially we can indicate which side is power side and which side is our ground side very quickly in most circumstances by where our load is. But if we come back to our series circuit, right, we can't simply say, oh, here's a load right here, so that has to be ground side. No, we have to also make sure that we are looking for any other loads in a series as well. Okay, so in this case, ground side that way going down, okay, and power side is in between here and here. Okay, and that's ground side as well. Alright, and we can do the same thing for this side. We can come in here, that side is ground. You know what, I'll even change different colors here. Here is power. Okay. Alright, let's go into something a little bit more complicated than just those examples. Alright. this time we're going to introduce a relay. Okay, so let's go ahead and draw that in here. So this is a relay, or at least a common symbol for a relay. And think of a relay as essentially a switch that is controlled by, it's a high amp or high current switch that is controlled by a lower current or lower amp circuit. Okay, so let me go ahead and erase this so that way we can get in and start drawing this. Alright, again, we start with ground. Okay, so I know that this is ground, and again this time it goes into my switch like so. Okay, I know there's ground here, and that's going to go into a motor. That's what this symbol means. Okay, and a motor is a load. And then we have another ground up here as well. That goes into my battery. Okay, so I've established all my grounds. Now we go into power. Power comes out of the battery. And again, it comes into a fuse or a circuit protection. I can continue out of that circuit, and I'm going to go into my relay. In my relay, I'm going to branch out here to the right, and it's going to end right there. And then it's going to go through here, and it's actually going to coil. And then it's going to come through here because the power is continuously going to keep flowing through that coil. Okay. And then what's going to end up happening is when this switch closes here, the power is going to continue to flow down and over to my motor. Okay, so let's kind of walk again through what this looks like. So we got relay here, and a motor here. So as my electrons are flowing through here, it's going to go into the relay. That winding, when we have a electrical current going through a winding, creates an electrical magnetic field. Okay, and the only way that's going to end up flowing is when this switch closes. Because currently right now it's open, but when it closes, then electrons will flow through here, and when it goes through this winding, or the coils, creates a magnetic field which then closes this switch inside the relay. When that switch closes, higher amperage current then travels this way and then flows into the motor to allow us to do work. So essentially what we could say is that this switch right here controls that switch right there, which then controls our motor. Okay, so we got a low amperage side and a high amperage side. So relays are pretty cool in that regard. Hopefully there wasn't too much John Madden going on here in this, but that kind of allows us to then be able to break down this diagram to allow us to be able to diagnose things. Alright, last thing that we want to talk about here real quick is an actual wiring diagram. So we established some very basic understanding of what's in a circuit and what every circuit needs, and we documented a few times, so let's actually put that to use. Okay. So again, here's my ground, and I'm going to establish that as green. Alright, so I'm just going to come in here and start highlighting this. Now, in this case, we haven't talked about this symbol right here that I'm encountering right now, and that's just basically a connector. And a connector is where the wire is spliced off, so I could disconnect this and take that apart. Okay, so, but we're going to continue flowing, and now we have kind of this box, and you can see that this box, let me actually highlight this box. There's a solid line box right here. I'm not highlighting it perfectly, but anytime you see a solid line box, it's going to essentially, the wiragram's telling you everything you need to know, all the components that's inside this piece is visible for you to see. If it was a diagonal, or excuse me, a dotted or dashed line box, it's telling you only the information you need to know in that particular wiring diagram. Okay, there's probably other parts to that that they're not telling you. So just keep that in mind. Solid line box, all the information. Dashed line box, incomplete information. Okay, so continuing on here, we go into this control module, or this box, and the magical box is going to be split off here to the right, and I'll be flowing over here like so, and then I hit a switch, and this switch is closed to ground, so I'm going to continue, keep going until I hit my motor. There, I hit my motor. In this case, go down into this switch, which is also closed to ground, coming here, falling into my motor there, which might seem a little confusing. Why would I have two grounds on either side of my motor? Wouldn't I want to have power on one side of my motor? Well, again, we're not quite yet done, so just trust the process. But I just keep following this up. So now I have my ground. Hey, one thing to keep in mind here, I'll just take a quick little commentary. You'll notice that here and here, I didn't continue that. That's because essentially those wires are not connected. Okay, if you look really carefully, you can notice that on splits, where a wire splits, there's a little dot there. Okay, we got to pay attention to that, because in this case there was no dot, which means those wires are not actually connected, even though they're overflowing one another. Okay, so I've established my ground side of my circuit. Okay, now we go to power. Okay, and now in this case, it says here, from power source system. Alright, so we don't actually have a battery on this particular diagram, but I can presume that this comes from the battery. So I'm going to come in here and draw this. Actually, you know what? There we go. This is coming from the battery, goes through my fuse, goes through a connector like so, continues on through another connector, into here, into another connector. But I'm keep going down here, and then it goes here. Now, because as we said before, this has a dot, it splices. So I can go this way, and it comes down here like so. And I come over here, and I split it that way as well. Then I can come over here as well, and slice down that way, and slice down that way. Okay, and in this case, I don't have a yellow or an orange in my circuit. Alright, which is kind of fun. So this is a really simple way to get started. So let's actually walk through and talk about what happens in this, because this is our power seat control. Okay, it says that right there. Power seats. So if I am sitting in my seat, and it's a toggle switch, right? So if I want to go move forward, what happens is this gets completed right here, and then electrons are able to flow this way, and actually goes down into my motor, and then travels up through the ground side like so. So in this case, what I'm going to have to end up doing is kind of having a double highlight. Alright, let me back all this up here quick. Okay, so let's see here. We also want to include this green, and we'll include that with some orange as well, because that does turn power and is part of our power side circuit when that switch turns on to move that motor, so that way I move forward. Okay, now if I want to go in reverse, what ends up happening here is I'll turn the toggle switch, and this then closes, and then now current flows in the opposite direction, and when it goes in the opposite direction, this comes up here. Now this side's green, and it reverses the motor. So pretty cool stuff in that regards. So again, just like I did previously, I'm going to take my orange, and I want to come in here and highlight this part. So this wire is actually doing double duty. It's green because it's hooked up to our ground, but then it's also part of our power side when it is established. Okay, so kind of fun. Honestly, you could probably make an argument that instead of this entire piece being green, including this side as well, you would probably want to make it both orange and yellow. Alright, let's see here real quick. So this would be orange, this would be orange, and yellow, because it is indirectly both. It depends on how that switch is turned on. So how does that affect our diagnostic? Well, if we notice that our switch isn't working, but it only works in one direction, that can allow us to very quickly determine what part of our circuit might not be functioning properly. Alright, so a lot of stuff to cover there, or we talked about. Quite a long video. But please make sure that you are going through and establishing the stuff that you know ahead of time. Okay, and so that is going to be very easily ground and power. Probably the two easiest things to get started with. Then, as you saw here on this particular wiring diagram, we broke it down to be able to understand, well, what happens when that switch opens up or when it closes. Okay, how does the electrons flow in the circuit? How are things connected? And then you can very logically say, if you can ask the right questions, you can find the right answers. Or if you don't know what the answer is, start asking questions to see if you can kind of figure that stuff out. Okay? Thank you again for tuning into this episode. Again, if you have any questions or comments, please definitely feel free to email me or throw out some comments on this video or in Google Classroom. All right? Have a good one, guys.